you can be the world's best motor control expert. How are you then going to connect to the cloud? Okay, you've got a real expertise in one area, but this is where the knowledge gaps come in.
From EE Tech Media, this is Moore's Lobby, where engineers gather to talk all about circuits. I'm Dave Finch. Today we're talking all about IoT edge processing with one of the thought leaders in our industry. If you missed our Industry Tech Days, then you'll want to listen to this conversation I had with Richard Barry, who is Senior Principal Engineer at Amazon Web Services and founder of Free RTOS, about the current state and the future of IoT edge processing. We discussed how today's requirements are both shaping and being shaped by the present microcontroller landscape, and how we can produce secure devices at mass production scales. But what you'll need to hear most, in my opinion, is Richard's take as the founder of Free RTOS on how engineers can future-proof their edge processing devices. Check this out. Welcome, Richard.
Thanks.
Yep, very glad to have you. And, I want to spend our time together talking about how the next generation of IoT devices, which will, of course, be processing at the edge, are going to bring new demands for sensing, media processing, and machine learning applications. But before we go there, very general question to ease us into this. What is driving the trend toward real-time edge processing?
Yeah, so I think the trend follows the trend towards higher value use cases in IoT. And, a lot of the higher revenue that's being generated per device comes from processing of the data. So the data is where the value is. At AWS, the trend is described as being fueled by three laws. So two of the laws have a big impact. The third one, I would say less so. But the first is the law of physics. This is to do with the need to drive latencies down effectively. Now, if you think of hot topics around machine learning at edge and this kind of thing, they're very processing intensive, and they just can't cope with the latency of going to the cloud and back. The second law is the law of economics. This is something we all understand, of course. Now, there is a cost to sending data. You can get a lot of value in IoT. There's lots of ways you can get value, but at its most basic level, just storing all your data, all your global data in one place and in one format, rather than distributed around the globe in lots of different database formats, allows you to get a lot more visibility and insights into that data. But at the same time, if you're on an expensive communication link or your messaging costs are high, then the edge processing allows you to pre-process, to filter, to clean, remove duplicates, and only send the data that actually gives you that insight and that value. So the value doesn't diminish, but your costs diminish by doing that edge processing. The third law, like I say, is a bit niche because it only covers a small number of use cases, and that's just the law of the land. If you're working in an industry where you don't have the freedom to send the data where you want, medical is the one that's always kind of highlighted there, but there are others. I would also add to that intermittent connectivity. A lot of especially remote IoT operations, if you're in a mine which is far away from civilization, you get intermittent connectivity. And that necessitates edge processing, so you can carry on executing even when the internet's not there. And then, when you get connectivity back, you can resync with the cloud.
That's brilliant. Thank you for that excellent overview. So with that, then how has this changed microcontroller applications?
Well, yes. The microcontroller applications have been changing continuously in the 25 years that I've been doing this. And one of the notable changes now, of course, is that microcontrollers are getting larger because the software is getting more complex. Obviously, the business models are changing as well. The growth of IoT itself was a big shift. I think because of the new challenges that come with the scale and the security requirements of IoT. So I think the differences specific to IoT, it's just that edge processing in IoT use cases is a lot more involved. Not just because of the additional number of libraries to be integrated, but also because it's I always struggle to say this, multidisciplinary. It's multidisciplinary in the sense that you've got the cloud and the edge. So the edge processing is obviously very different to the cloud processing, different skills required, but also in the edge processing itself. And this kind of generates knowledge gaps, if you like. There's a couple of kind of use cases, which are hypothetical use cases that I kind of tell to make this point. The first is regarding motor control. And I choose motor control because it's a very sophisticated but small. You can do an awful lot with a small amount of code. And you can be the world's best motor control expert with more PhDs than fingers in implementing very tight control loops. Maybe you're just writing in assembly because it has to be very fast.
Right.
And then I was just mentioning a moment ago the business models that are opened up by IoT. So if you then want to add value to that with something like predictive maintenance, then you're going to have the actual predictive maintenance algorithms. Maybe if you're the PhD dude, then that's fine because that's very mathy and the motor control is very kind of mathy as well. But then you've got the connectivity as well. So how are you then going to connect to the cloud? Okay, you've got a real expertise in one area, but this is where the knowledge gaps come in. And I can kind of demonstrate this on a couple of diagrams here. So this first one is the structure of what that motor control application might look like, right? And you can see just how simple this is without connectivity. There's hardly anything there. You may have those drivers or you may not. And this second diagram shows the same thing, but this time with connectivity. And you can see the number of additional libraries. And these kind of cascade from each other. So first you have the base connectivity. This is like the TCP/IP that everybody's aware of. And then the higher level protocols like MQTT. And then you get into the more complex and esoteric protocols like TLS for data encryption. So TLS is the protocol that everybody kind of uses every day, maybe without realizing it. Every time they do an HTTPS, it's using TLS to encrypt the data that it's sending.
Okay.
And important, and it's not just the encryption, but it's also the authentication. So if you are an edge device and you're connecting to the cloud, you have to authenticate that you're connecting to the correct cloud. Likewise, the cloud has to authenticate that the device connecting to it is authorized to do that. So then that gets into the secrets you need to store on the device in order to enable that authentication. So you can see this kind of whole cascade. I can flip that around a little bit and demonstrate this difference between what we call the differentiating functionality and the non-differentiating functionality.
Great.
If we go to something like a light bulb, so in this diagram now, I'm showing this super duper fancy light bulb on the left-hand side. This does everything and more you would ever want for a light bulb to do. I'm not saying here that light bulbs are a good way of demonstrating value in IoT, by the way. I'm just using a light bulb because it's the most base thing that everybody understands how simple it is.
Sure.
So maybe this is like flashing in time to music, fading in and out, presumably turning on and off at some point. On the right-hand side, we have the program space. This is the memory map that holds the executable code. At the very bottom here, I've shown that very small kind of segment. That is implementing that differentiating functionality. What makes that an all singing and all dancing light bulb? And then you can see all those other libraries I've just mentioned take up the entire rest of that program space. And that's where the complexity comes from. And that's all undifferentiating. You just have to have that in order to connect.
Right. And so, I mean, these are obviously these are demands, pretty sizable demands that we are placing on these types of devices. And it's sort of like one side can't come up without the other. So what is the maturity level of IoT adoption? How are you seeing that sort of evolving?
Well, I'll say it's kind of coming in phases. I mean, I think everybody understood the value of IoT very quickly. We're just talking about predictive maintenance, for example. That can save you a lot of money because you're not going out and servicing equipment that doesn't need servicing. And it can really please customers because their products or their motor never breaks. It tells you before it's going to break and gets fixed. So, the value is obvious. And, there's a kind of a rush towards it. But then, even the embedded experts, not just the motor control experts, but the embedded software experts began to realize that, perhaps this was a little harder than we had hoped for. And I think I just demonstrated some of the reasons for that, this kind of integration of undifferentiating functionality.
Right.
Yeah. And now I think those kind of integration challenges are largely behind us. I will say what I always describe as a kind of coming of age of IoT, because now those are being tackled. The challenges we're presented now are a lot more nuanced. And people are kind of realizing that the original problems, which we thought were harder, are actually the easier of the hard problems to fix.
Right. You just used a very interesting phrase that I tuned into right away. Can you explain a little more what you mean when you say that this is the coming of age for the IoT?
Sure. So I think, like I just said, it's the second round of challenges here, and I think security is the obvious one. So what I mean here is you've got the base functionality, TCP, and how you integrate that with TLS and all that kind of thing. And then when you look at the nuances of security, we talk a lot about security, especially if IoT have physical access to devices, and a lot of IoT devices are useless if you don't have physical access. So that's just a given. Right. There's a lot written about securing IP, securing privacy, security from running malicious code, IP theft, counterfeiting. But the more nuanced part that comes with that security is I kind of hinted at it already, this authentication. And that means that you need to make each device uniquely identifiable somehow in order to get that authentication. And that throws up real practical challenges. And this customization, if you like, is what we call provisioning. So somehow not all devices are going to be the same. And I think the one way I can describe this that everybody understands is when you buy a new device, that maybe it's a cell phone or something like that, and you need to connect it to your home network, you need to give it the Wi-Fi password. So you're provisioning that device with that password. If you think about that's a one-to-one interaction, and it's okay for that person to do it. If you think about IoT, you might have hundreds of thousands of devices, and there's no one-to-one interaction. So somehow you need to customize those devices so they can uniquely authenticate themselves to the cloud, and also understand which cloud is authenticating itself to it, so it doesn't just connect to anything. So that's the first challenge. But the real challenge then is how do you do that customization at huge scale? IoT is all about scale.
Exactly. And I mean, the scale is key. And part of the scaling kind of in the same realm as the complexities and some of these problems that we're solving for. Like you said, maybe the motor control expert wasn't exactly an IPv6 or networking expert, right? And so
exactly, yeah.
Provisioning a device, ideally you're making it as easy as possible for the end user. Let's say it's a smart factory or a smart building, and we know that the person who's probably installing those devices and gateways might not be a double E. And in the case of maybe residential water metering, they might be truly a plumber. Is that's not exactly in the profile of that trade is provisioning devices, right? So we need to make
exactly.
need to make it very simple for these devices to join a network securely and everything else. So this comes down to not exclusively, but majority is software. So what would set software solutions, particularly those offered by AWS, what would set these apart in terms of, say, cost, ease of use, that sort of thing?
Yes. So before I answer that, I should say that when we get these secrets onto the devices, the software on the device has to manage those secrets as well. By manage them, I mean not expose them. And there's lots of different ways of doing this, and FreeRTOS is used with all of them. But the thing that's in common of all of them is the API we use to actually access those secrets. So we use something called PKCS11. PKCS stands for Public Key Cryptography Standard. I got that right.
Okay.
This is a global standard that's used all over the place, and you require a bit of hardware support here as well. And this allows the software to access the secrets, which are normally private keys and certificates, without actually having to read them out. If you read them out and hold them in RAM, then they're exposed. So this interface allows you to access them just with handles, and they can stay within secure hardware. There are lots of ways of doing this. I wouldn't say they're just software, and there's a lot of research and new methods coming out to do this. If you do, the first thing you have to do really is decide when you're going to do this customization, because you can do it when you manufacture the part, when you assemble the part, or after the part has been assembled and you first turn it on. If you do it at manufacture time, then you have the challenges of distributing those secrets to the manufacturer, how the manufacturer controls those secrets, how access to it during the manufacturing process. And there are companies solving this problem. We've worked a long time with a company called IER. They have this secure things, and they're actually building. They have a whole development. They're famous for development tools, and into that tool chain now they're developing this provisioning workflow, but not just at the development tools, but also to then distribute those keys and then inject them in a secure way. Now that that adds to BOM cost. Obviously contract manufacturers are going to charge a little bit more. So as you say, there are lots of software ways of doing this as well.
Right.
So traditionally, there's something called a certificate signing request. So here, you would manufacture a device with a certificate on it, but then you have to trust that certificate. And to do that, you would sign that certificate. And again, this is, if you think of your web browser connecting to a bank, it obtains a certificate and it checks the signature against, there are a few companies in the world that are trusted as root to provide roots of trust, and they sign that certificate. So what's happening in the background is that certificate is signed already, and you're checking it. Your web browser checks it, and if it doesn't trust it, then it'll tell you not to access your bank account or something. So that's about as simple as I can. It's a lot more complex than that. I'm trying to explain it simply.
Right.
So a certificate signing request, the device has the certificate, and it's then asking for it to be signed. To do that securely, you need to be able to uniquely identify the device still. And this is where, coming back to how microcontrollers are changing, there are lots of microcontrollers coming onto the market where, the manufacturers are cognizant of this and providing mechanisms of doing this. So you can have a database of IDs of devices. You get a certificate signing request, check it, make sure that that device is in your database and sign it and send it back. As far as Amazon specific ones, then there's actually a whole set, and I think each one they all fulfill different use cases. Put it that way. The first would be something called just-in-time registration. Now, that signing certificate or the trusted certificate, sorry. If you're using just-in-time registration, you would upload that to AWS. You'd probably not have your root certificate there. You'd have an intermediary certificate, but the important thing is that's the trusted certificate.
Yeah.
That would sign the certificates which are on your individual devices, but you still have to have a unique certificate on each device.
Right.
And when that device connects, it offers up. You don't have to register the device. This is the big thing. You don't have to pre-register the device. When it connects, it presents its certificate, and as long as it was signed by that trusted certificate, it's registered at real time. So this is a really big boon for mass production, but you do need to still customize each device. There's also something called just-in-time provisioning, which is similar, slightly different workflow, but similar.
Okay.
After that, the next thing after that would be something called fleet provisioning by claim. So this builds on top because it means you don't have to have a unique certificate on each device. And the way this works, in fact, I can show you this little diagram of the workflow here.
Sure, yeah.
The way this works is that you actually put the same certificate on each device. This is what we call a claim certificate. Now, the claim certificate doesn't allow that device to do anything other than go through a process of getting its real certificate. But the big boon is here that every device has the same claim certificate per manufacturer. I don't mean every device globally,
right?
Per product family.
Sure.
And then you can see in this workflow that it connects using this claim certificate. That's recognized, and it goes through this workflow. And out the other end pops its real certificate. And there's what we call a provisioning template. And the cloud side is responsible for generating the certificate, using that template to say what that certificate authorizes that device to do. For example, which endpoints can it connect to? When it's connected, what can it do? Can it just send data, or can it read data? And there's a whole load of other things. There's a whole raft of cloud services that you can access, and you can get very fine-grained permissions in order to do that. Sure. There's a slight different way of doing that, which is called fleet provision by trusted user. In this case, the authentication comes from the user. So the user has a cell phone, they have the device there with them. So there's that trust because of the proximity between the two. And what they do is they authenticate, and at the time that the user authenticates, it generates this claim certificate at real time, at runtime. The big thing here is that claim certificate then only lasts short time. I think it's 5 minutes. And the cell phone sends it to the device, and then the process that we just showed on the screen kicks off from there. That's obviously limited to the use case where there is this person who is customizing the devices as they're installed. That's more common than you might think. And building control systems are installed by operators, so they can do that. The final one then is what we call multi-account registration. Now this gets around having to upload that certificate, your own trusted certificate. So you can see how these things kind of build on top of each other.
Right, right.
This also allows you to, rather than having to upload a certificate to one global region, you can have true global product distribution. There are lots of ways there are lots of benefits this provides, but I realize I'm going on a bit here, so let me just describe one of them.
Yeah, this is great, by the way. I love this.
Yeah. So the best way to use multi-account registration is actually to use something that we call a secure element. There are lots of manufacturers that provide secure elements. These are silicon components that are hardened, they're tamper resistant, and they can come with a key in them already. And then you connect them to your microcontroller over some serial bus. And again, the software then, or at least our software, different ways of doing it, uses this PKCS11 to access the key. So there's various different layers of security here. Mm-hmm. Now, it used to be that you could buy these with your certificates in them, but then that part number was unique to you. So that meant you had to buy a lot of these devices in order to make it economically viable. Right. What multi-account, or just one way that multi-account registration helps, is that now you can buy these things, 10 at a time, because they're all the same, because they're not now unique to you. What the multi-account registration allows them to do, when you can have millions of these on the shelf, you just buy 10. When you turn it on, it's going to connect to an account that understands who bought that device or which company bought that device.
Okay.
And then what it can do is hand over the certificate to that end user's, or it might be the middleman, or it might be the end user's account, and authorize the device to connect to that other account. It tells the device where to go and connect, and this can repeat as it moves around the globe, or as it's sold from the manufacturer to the distributor to the end user. So here, like I say, this is very, very close to a kind of zero-touch approach as far as the users are concerned. Obviously, the designers have to think about these things.
Hey, everybody, this episode is sponsored by Maxim Integrated. Maxim Integrated is an engineer's engineering company, which means that they solve the toughest circuit design problems to empower your design innovation. To help you quickly develop smaller, smarter, and more secure products, they're launching their Virtual Electronica 2020 experience, packed with opportunities for you to deepen your expertise. Dive into demos, gain deeper insights into technologies through their series of webinars, and meet with their team starting on November 9th. For more information, visit maximintegrated.com. Design engineers really have a lot on their plate when they're trying to develop a platform such as this, not the least of which being future-proofing. So how can design engineers future-proof their edge processing devices, especially when all of this technology is evolving so quickly?
Yeah, that's the key, isn't it? That things are evolving very quickly. And I think one of the fundamental point here is that when you distribute your devices, you don't have physical access to them anymore. You can ask people to go and plug in a USB, into their device and update it, but that's not a great user experience. So being able to update your device over the air is kind of fundamental, because today, and by that, what I mean is, you may have a new executable code that you want to send to that device. This is what we call over-the-air update. And that enables you to change all the software on there. I mean, you could even change from one cloud provider to another. And this is, that's kind of future-proofing, right? But I think the fundamental point here is that today's security technology, the cutting edge today, is not going to be tomorrow's cutting edge. So you're always going to have to consider how you are going to update your devices, if for no other reason, to patch, as security is advancing. We were talking about TLS. Prior to that was SSL, and everybody used SSL. There's vulnerabilities found in it. People moved to TLS, so who knows what's going to be there tomorrow. Other than that, we've seen how IoT devices have a lot of undifferentiating functionality. So you want to reuse as much as possible. You don't want to keep reinventing that, especially with this knowledge gap. So I think the key is to do as little, be as lazy as you can. Do as little customization engineering as absolutely possible while staying in control of your destiny. Using libraries that are pre-integrated and tested. We saw some diagrams of that before. In fact, if you remember this diagram here, where I showed all these different libraries, then you can go one step beyond that and say, okay, all these libraries come together, but we can also get these libraries pre-integrated and pre-tested and even qualified as functioning. And if I switch to this next diagram, you can see how we can make people's lives much, much simpler. And in here, we're adding in the kernel as well, the FreeRTOS kernel, the scheduler, the real-time operating system, whatever you want to call it. That introduces multi-threading, and that in turn then enables us to give a very, very simple application level view of the code. Talk about over-the-air update, that's quite a complex process, but using this scheme and the multi-threading, you can just start the over-the-air updates agent in the background, allow it to do its thing, it downloads codes, checks the signature of the code as well. Again, we're checking signatures to make sure things haven't been tampered with and that they're authorized. And then just tells you when a new one, a new executable is there. So, we can really simplify things by choosing things which are pre-integrated and pre-tested. And then you just add, remember that the differentiating part we looked in that light bulb diagram. That's the
Right.
bit you add. But secondary to that, use cases are so diverse. So when you use these libraries in an integrated form, you also probably want to make sure that you can use the libraries individually as well. Now, this is particularly important for very small microcontrollers that you don't want all that. You don't even want multi-threading. But if you think about what we call greenfield devices, these are devices that they've been deployed already, but you want to update them for different forms of connectivity. So in this diagram here, what I'm showing is some of the work we are doing to take these integrations of libraries. As we move more into the official FreeRTOS distribution, we're actually kind of decoupling them and breaking them down to the most basic functionality. And that then gives you the flexibility to use that by itself, like I say, on a very small microcontroller. Or you can then couple that, in itself is completely decoupled from everything, including the operating system. You can then build on that with this kind of agent that I was just describing and have just that piece of functionality with a simple interface. Or you can go the whole hog and have the complete integration. So this is the flexibility. So that's another thing for kind of future-proofing. You don't know what your next application is going to be or in 5 years.
Right.
Yeah. I think there's things like open source can help with business risk mitigation. You may want to delegate responsibility. You may want to buy rather than build. But I think, IoT devices, they're in the field a long time. So if you do use a commercial vendor, you at least want to make sure you have access to the source code and you know how to build it and patch it just in case they're not there to help you.
Mm-hmm.
And finally, I think choosing the cloud vendor is the same, right? Like I said, it's multidisciplinary, that word again. So the same goes for the cloud. You want to make sure that your cloud vendor is able to keep up. They're able to scale, but the velocity at which they add features and the velocity at which they adapt is very high as well.
Yeah.
There's a lot there.
There is, and so much of it is stuff that, is just truly unknown. Like you said, we don't know what the landscape is going to look like in 2 years. We don't know what weaknesses we haven't discovered yet. Use cases, business models. So the best you can do is what you're doing, which is enable sort of at a global scale the most flexible, secure, viable architecture to account for all of these things. It's that's the only way to achieve scale. This is, man, my head is spinning, and this has all been so insightful. I know that our audience has questions for you as well, Richard. So let's take a few of those now. And by the way, for those of you watching, all week long when you're watching these live keynotes, you can ask questions in real time by using the chat widget there. So, let's start with this one. This is Paul from San Antonio, and he asks, how do you prioritize developments given FreeRTOS has wide use on all microcontrollers, big and small, but IoT needs relatively powerful microcontrollers?
Right. So, I would say that FreeRTOS has always prioritized its development with whatever the demands of the day are. And obviously, there's a big demand for IoT now. Mm-hmm. But FreeRTOS has a huge install base. So we're talking specifically about IoT here, but all the other use cases don't go away. So we prioritize the same way. We always have. We're obviously investing a lot in IoT at the moment because that's the growing area. That's the volume area. FreeRTOS is very, very customer driven. But say, is it customer? I don't know. With open source software, it's user based,
right?
User based driven.
Yeah.
So you can look at our code is in GitHub, so you can go and have a look at some of the developments we've done. So you can see that the kernel is under active development. We're adding new features into the kernel. We're adding new architectures. We've just actually released a whole load of new demos for 8-bit AVRs, AVR microcontrollers, and that's there's nothing to do with IoT.
Right.
And I think now I'm working with Amazon who are being a fantastic sponsor and bringing all sorts of value to the whole FreeRTOS user base, where we are able to concentrate on many things at once. So we have a much larger team. So we've got teams working on IoT and teams working on kernel development.
Yeah,
I think that's a very interesting angle as well. Some of the value that having a big backer and a big sponsor like AWS bring, because obviously they have an interest in IoT, but there's a lot of work which is being done. Things like mathematical proofs for not just thread safety, but memory safety, and the kind of global presence that they bring. And it's important to note that all these benefits are being added to code which is MIT licensed. So there's no link. You don't have to be an AWS customer. Doesn't matter. I said that there's huge install bases outside of IoT, and all that work with that larger team and all that more focus on things like mathematical proofs is just available to everybody. So if you're slightly concerned that we're focusing on too much on IoT, just go and have a look, and you'll see that this larger team is bringing huge value to anybody, no matter what their use case or what they're even if they're connecting to a different cloud.
That's a really good point. The context of this discussion this morning is IoT, and that's kind of the parameters, but for the most part. But that's a really good point. And by the way, this is a completely impertinent question, and not one from our audience, one from me. Do you have like a slow gear? Because it occurs to me. I mean, you founded FreeRTOS, which is incredible. The being able to implement an open real-time operating system on virtually every microcontroller manufacturer you would want to have supported, and then keep that supported, and then now extending this into IoT and doing it in conjunction with Amazon. I mean, good Lord, you're you're killing it, as they say. So here's a question from Rahan in Cologne. Hello in Cologne. Good afternoon, I should say. Rahan asks, what range of solutions do engineers have available to them for the implementation of edge processing in real time? Good question.
Oh gosh, there's an infinite number of solutions, I would say. Of course, there's a lot of I'm very much focused on microcontrollers, and I suppose one extreme of solution is that you just go and develop everything yourself. You can develop the hardware even and the software without any pre-integrated and provide your own cloud service. I would strongly recommend not doing that for the reasons we've just been through. You're doing all that undifferentiating work that people who are experts in those fields have done for you.
Sure.
Right to the other extreme of a big Linux system, which is very, very powerful and very, very common in edge processing as well, especially in things like gateways. If I can narrow it down to AWS, and obviously I'm emphasizing the point that there are a huge number of options here, but at AWS we have many, many different SDKs with software development kits, which are in lots of different languages, Python and Node and all these different things. We have obviously FreeRTOS, which we've spent a lot of time talking about. There's a C SDK, which is RTOS agnostic as well. And as time goes on, we're sharing more libraries there. So a lot of the refactoring work that I've been talking about is going to apply to the C SDK and FreeRTOS.
Mm-hmm.
There's a product called Greengrass. Now, Greengrass is not an operating system, but it runs on Linux. That enables you to, it enables you to do lots of things. I'm underselling it here, so you should go and read about it. But a few things that allows you to do is take some of those cloud services and actually move them to the edge. I mean, this is, very pertinent to the first question about, how. How the things are being driven to the edge. So a lot of the cloud services you can develop in the cloud and run on the edge now. using Greengrass to get access to some of those AWS features. But more than that, it allows you to run, manage, run, deploy, monitor lots of different applications, particularly in things like containers. So it's not just AWS services. You can use the device management and the provisioning and that kind of thing, but then just run your own applications in the Greengrass environment as well.
That's awesome. And that you said that runs, I'm not familiar with it at all. It runs on Linux.
Yes.
All right.
Yes.
That's all right. I am going to go check that out. But first, a couple more. Lara from Markham, presumably Ontario, has an interesting question because we were just talking about this a little bit. She says, free RTOS is used with all cloud services. Can we expect this playing field to stay level with AWS now being involved?
In the reality, the reality is yes. The reason I say the reality rather than some of the perception, AWS are obviously sponsoring a lot of the work, so we have a lot of examples which are connecting to AWS, and there's a lot of we can draw a line between what is open standards. In fact, when we were talking about future proofing, what I should have also spoken about is open standards. So in FreeRTOS, we always make sure that we are using open standards. TLS is not something which is particularly suited to a microcontroller space, but we use it because it's an open standard and it's trusted much more than if we were to write something ourselves. So
sure.
Things like TCP, which we're doing a lot of, again, we're doing memory safety proofs on TCP. And some of our examples are connecting to AWS, but we also have examples which are connecting to completely neutral places. There are some public MQTT, which is another protocol which is used a lot in IoT. So we're connecting to, what was it called, Mosquito, which is a completely neutral MQTT broker as well. So there's it's MIT licensed. There's a lot of work going into it. It's open standards. You can connect to anything you like with it. The other side of that is the AWS specifics. So there's less portability in the clouds, of course, and of course we are keen to demonstrate some of the real value add in AWS. So over-the-air update, there's a fully managed over-the-air update service. And some of the device, the fleet provisioning that we spoke about, this is kind of AWS specific. And we've done a lot of work to hopefully demonstrate that we are still, you can still connect to any cloud you like by deliberately separating these two. And in fact, in this diagram here, you can see how the generic protocols, I'm not sure how to describe them, the standard protocols are being moved into the freertos.org Git repo. This is a slightly expanded view of the diagram I showed before. And the AWS specifics are separated out. So is it still a level playing field? Yes and no, in the sense that we're doing a lot of examples that connect to AWS, but you can take that and connect to anything you like. FreeRTOS has always been open and neutral.
Right. No, that's really good. There is sometimes that gap, right, between what's real and happening versus perception and sort of assumptions. But no, that was really interesting. So we have time for one more. This is Andrew. He's in Crystal Lake, Illinois. Andrew has a good question here. So, Richard, what are your predictions for the next few years in IoT?
Great. So yeah, I mean, I could talk about this. I'm going to go through this very, very quickly. Otherwise, I could do a whole half hour on this. So everything starts. Well, some things you can see happening already. So I'm going to distinguish between what you can see happening and the predictions. So
cool.
The first is an increase in coordinated attacks on IoT devices. I mean, it's well known now that there are legacy devices in the field that don't have great security. And you can say that's a bad thing, or you can also say it's a good thing. So that leads on to, or that prediction is perhaps somewhat obvious because something you can see in the field already is an increase in legislation, okay, to protect consumers and consumers' data. Mm-hmm. So you can see that already. It's not really a prediction, that part of it, but developers are then forced, because of that legislation, to actually do, due diligence on security, which then increases the need for doing a lot of these things that I was talking about, provisioning at scale. So that's going to become more and more important. And I think also developers are going to increasingly realize that device-side security is perhaps not always enough in itself. If you have physical access to devices, then, with enough motivation and enough equipment, eventually things will get broken. This is where the need to update as well comes in. We've also spoken about. So my next prediction is there's an increased amount of coordination or responsibility between device-side security and cloud-side security. So the cloud-side security can do things like audit devices, make sure they're set up correctly, audit how they're behaving just in case there's some malicious code running on there. It can monitor whole fleets of devices and look for patterns. It can then close the loop and update devices. It can take devices offline if they think they're behaving in an anomalous way. So I think the synchronization between cloud and device security is going to become more and more important over time. And that then leads to that forced need to think about security and all this innovation which is going on now, both on the device and on the cloud, and the coordination between the cloud and device will over time increase people's confidence in products, and that will increase adoption. So you can see a kind of cycle here.
Sure. And key learnings from the prior 6 months or the prior 18 months obviously inform sort of where the industry collectively goes next, and subsequently. And like you said, the more these devices become ubiquitous, commonplace, and consumers are I see the occasional scare article about, what is your smart speaker really listening to? It's like, none of us really, there's probably a handful of people in the world that truly understand. The rest of us are just speculating, right? So the more that we have good experiences and good trusting relationships with these types of devices, the more this scales. And then again, that's why we're engineering for scale now. So this has been amazing. Like you said, I feel like an hour wasn't long enough, and a really fun way for me to kick off this particular week-long event. Richard, thank you so much, and thank you all for joining us. Yeah, and by the way, let's do this again.
Yeah, sure.
Awesome. Hey, if you're watching this live, you've got a full day of live sessions ahead of you. It's not just this one, so be sure to reach out and connect with other attendees throughout the day, including the presenters, by the way. They'd love to hear from you. I'm going to be on there as well. So enjoy your day, everybody. Richard, thank you so much.
Oh, thanks for having me. It's been great.
You bet. And for those of you at home, we'll see you tomorrow. Once again, that was Richard Berry, Senior Principal Engineer at Amazon Web Services and founder of Free RTOS. The conversation was recorded on August 31st as part of Industry Tech Days 2020 on allaboutcircuits.com. In our next episode, we'll chat about online learning for engineers with Anant Agarwal, founder and CEO of edX. As always, please leave us a review, send us your comments, and subscribe to Moore's Lobby on allaboutcircuits.com. Thanks for listening.